Here's another example of a limiting reactant problem for you. So if we've got heating together the solids, ammonium chloride and calcium hydroxide can generate ammonia, which is nitrogen trihydride, aqueous calcium chloride, and water. Okay, so the first thing we want to do before I even read further is write out my balanced equation. So I have, ammonium chloride is NH4. He's a positive 1 and chlorine's a negative 1. So I'm going to have NH4Cl. And he's going to be a solid, they said. And then plus calcium hydroxide. Calcium is a positive 2. Hydroxide's a negative 1. So I get CaOH in parentheses 2. And I said that was a solid. And it tells us that it's going to produce ammonia, which is nitrogen trihydride, NH3. And it's going to be a gas. It tells us calcium chloride. So calcium's a positive 2. Chlorine's a negative 1, so CaCl2, and they said that was aqueous, and then water. Okay, so this is a liquid. And the reason this guy is aqueous, coming from two solids, is because since water is produced from this OH and the hydrogen over here, the calcium chloride then forms a solution because he's in the water. So that's why, in case you were wondering, how did I get an aqueous when I didn't have aqueous over here? So now we have to go through and balance this. So I'm going to start with my nitrogen. And on this side I have 1, and over here I have 1. Okay, so far so good. Chlorine, I have 1, and I have 2. So I'm going to come over here and make this a 2. Well, that just made my nitrogen 2, so I'm going to come over and do that. Okay, so my calcium is good. I've got 1 and 1, and now I'm going to go to my hydrogen. So I have 2 times 4 is 8, plus 2 is 10. Over here, I have 2 times 3 is 6, plus 2 is 8, so if I make this a 4, that should give me 10 of them. That gives me 2 oxygen, I'm balanced. So my coefficients are 2, nothing, 2, nothing, and 2. All right, so we wrote the equation. Now we can go back to the problem. And I spelled reactant wrong, sorry. This is if we have 33 grams of each reactant, so 33 grams of this one and 33 grams of this one. I want to know the theoretical yield of ammonia. So I'm trying to get to this guy. So we set up our two problems. I have 33 grams of the NH4Cl, and I have 33 grams of the CaOH2. All right, so we set them both up, and we make our way over to the ammonia. So I'm going to go grams, and I'm going to go NH4, and then dot, 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 because I'm going to run out of room. Do the same thing, and then go moles of NH4 to moles of ammonia. So this is NH3 up here, and then go again, and I'm going to go moles of NH3 to grams of NH3. And then down here, I have to go to the same place. So I'm going grams of Ca, and I'm going to go dot, dot, dot to moles of Ca. Again, moles of Ca to moles of NH3. And then moles of NH3 to grams of NH3. And remember, because you're going to the same place, this last little tetras piece is going to be the same. So down here, I have 1 mole equals nitrogen's 14, hydrogen's 4, or 1, but there's 4 of them, so there's 4, and chlorine's 35.5. If I add all those guys up, I get 53.5 grams per mole. So the grams goes away. Mole to mole. There's 2 NH4Cls for every 2 ammonia, and there's 1 mole for this molar mass, which this guy's 14.3, so you get 17. I multiply everything on top, so 33 times 2 times 17, and then equal. I'm going to hit divide, left parenthesis, 53.5 times 2, right parenthesis, and hit equals, and I end up with 10.5 grams of possible ammonia formed up here. Okay, so now I'm going to go to the calcium hydroxide. 1 mole gets me the mass of this. So this guy's 40. Oxygen's 16, but there's 2 of them, so there's 32 and 2 hydrogen. I add all those up and I get 74 grams. Crossing off my labels. Mole to mole, so there's 1 calcium hydroxide, and there's 2 moles of ammonia, so 1 to 2. Cross off my labels. And then 1 to 17, just like there was before. Okay, so I take 33 times 2 times 17, hit equals, and divide by 74, and I end up with 15.2 grams of ammonia. All right, so in this case, my limiting reactant is the ammonium chloride. My theoretical yield is 10.5 grams of ammonia because that's the best I can do between these two numbers. Okay? All right, so limiting reactant then, because this product was the smallest, the limiting reactant is NH4. NH4Cl is my limiting. That means the calcium hydroxide was the excess because it would have produced more. Okay, so I'm going to erase this top problem right here for us to do the last two problems. Okay, so this one's set up a little bit different. It says that I have 85.4% yield. So I'm going to do this because I know that 85 is going to be divided by 100 to get it to something usable. Actual over theoretical. Okay, theoretical, we just found out was 10.5 grams. So if I multiply my 10.5 times my 0.854, that should tell me how much I had in the lab. So I multiply those two things together and I get 8.97. 8.97 grams obtained in the lab. Okay, so that's our answer to number 3. All right, the last question then, how much is excess? So I'm going to erase this last little piece that I just did here because I want to keep the bottom one. Remember, to figure out your excess, you're going to take your theoretical yield and you're going back to the excess. So it's just the opposite of this problem. So we had 10.5 grams that we said ammonia could be produced, theoretically. So now I'm going to go grams of ammonia to moles, that's a 3. Okay, go again, moles of ammonia to moles of the calcium hydroxide, because this was the thing that was supposed to be excess. And then moles of CaOH2, 2 grams of the Ca. Okay, and like I said, we've already done the math on this for the most part because it's just reverse. So if we go moles to grams, it's 17 grams for 1 mole. So remember, it's the step flipped. Moles of NH3, there's 2 of them. For 1 CaOH2, it's the step flipped. And then 1 mole is the mass of calcium hydroxide, which is 74, so it's that step flipped. Okay, so now to enter it in my calculator, I take my 10.5 times 74 equals, and divided by 17 times 2, which is going to be 34. So when we do that, we end up with 22.9 basically grams of the calcium hydroxide that was used. This was used, don't forget. So if we started with 33 and we used 22.9, okay, because we started with the 33, we can subtract the 2 to figure out what was left over, and 10, I'll go right here, 10.1 grams of CaOH2 was left over unreacted. All right, so those are 2 problems, like I said, that you can go back through these videos and watch them and stop yourself and see if you're doing it right to check and make sure you're ready for tomorrow. And tomorrow just is 1 problem like this, just 1 problem, and that's it. All right, good luck.